Okay, welcome to the second part of the problem. So let me just give a prelude of what we have seen so far. So this is what we had considered. We looked at, okay, what do you mean by gravitational field, mass of a particle, charge in a particle. We described all this in the previous video. And now what we have done is, after this we came across the ratio of the electric field to the gravitational field, and we got the magnitude of it, order of the magnitude. And then after this we looked at one problem. Earlier we had chosen this time to be around 7 minutes, and we were able to complete it in a much faster pace, okay, because the total problem size is around 15 marks. So we thought we'll do it in 15 minutes, but we already finished 9 marks over there. We are still left out only with 6 marks. Okay, so I have just chosen for 6 minutes over here. Okay, let me start. So what we did here was that we took up two plates, connected this to a potential difference, put an ionized hydrogen, which means what? Only one proton. Okay, and then a potential difference V was applied, and as a result of this, the protons that were present over here were getting ionized, and they started moving upwards. And because, sorry, not upwards, it was downwards. I'm sorry, this one, it was moving downward. Because why downwards? Because if this is positive or negative, a proton should be here, it will get repelled by this one, so it should move downward like this. Okay, so as a result of it, moves downwards, and as a result of it, the acceleration, each ion gains an energy of 1.9 into 10 to the power minus 18 joules. And then based on it, I asked you to find out what is the potential difference that was applied. We got it as 12 volt. Okay, now let us move on to the next one. The plates in C are replaced by a cell. So we had two plates like this, right? We had two plates like this. Okay, replaced by a cell which has an EMF of 12 volt. Now this was, so first let me write down the diagram how it was looking like this. It was looking like this over here. Earlier it was looking like this over here. Now what I did was, I am replacing this one with a cell. Okay, which means this is replaced with a cell. Okay, that has an EMF of 12 volt, the same EMF, whatever potential it had, an internal resistance of 5 ohms, 5 ohms, okay, which means I am writing something like this, 5 ohms here instead of writing it here. A resistor of resistance R is connected in series with the cell. A resistance of R is connected in series with the cell. R, the energy transferred by the cell to an electron as it moves through the resistor is 1.44 into 10 to the power of minus 18 joules. So what is asking? Let me complete the circuit like this. The energy transferred by the cell to an electron is, as it moves through the resistor, the energy which is dissipated here is given as some value of E, which is given here. Okay, given as E here. Now define the resistance of a resistor. What is the resistance? How much mark? 1 mark here, right? Which means it offers opposition to the flow of current. You can define it like this. You can also define, instead of this one, you can also define resistance is equal to ratio of applied voltage to the current passing through the circuit, passing through an element. You can mention like this also. This would be more appropriate, because here an opposition to the flow of current can also happen by means of an inductance or a capacitance in case of an AC circuit, and that will refer to as reactance. Okay, here very clearly it is mentioned as resistance. Okay, you cannot mention DC circuit also here, because resistance occurs even in the AC circuits also. So the better way of writing it is something like this. This would be a better way instead of writing this. Of course, this also mentioned logically the same, but this would be the better definition of writing it. Okay, now let us move on to the next question. They are given so much data. Show that the value of R is 15 ohms. The value of R is 15 ohms. So how do we do this? So once again, look at this here. You have a 12 volt battery. Let me write it down here. You have a 12 volt battery. You have a 12 volt battery over here. 12 volt battery, a small internal resistance of 5 ohms, and a big resistance of R over here. And the value of energy dissipated here is given by, how much is the energy given by? 1.44 into 10 power minus 18 joules. 1.44 into 10 to the power of minus 18 joules. This is what is being given. Now how do we do this? Now, what happens is, see, the potential difference across these two ends, namely A and B, if I is a current passing through the resistor, potential difference across these two, VAB, can be written as 12 minus 5 times I. I can write like this, right? Because some amount of potential difference is dropped here. I can write this 12 minus 5I. Now this appears here also. Okay. Now energy is given. What is energy over here? Energy over here is nothing but Vi into T. Okay. If I put T equal to 1 second, then I can say V into I. What is V here? V is already got. I is the same current over here. So I can now write, but I need the value of current here, right? The value of current is not known. So what do I do? There should be some method to do it. Okay. Now what we will do is, we will do like this. Just a minute. Let me see what best can be done. Okay. Let me do it like this. See, when a current passes like this, the work done here and the energy here are one and the same. So what I will do is I will not use this approach. I will use Q times delta V is equal to E. Okay, E over here. Okay, energy spent over here. What is Q? Q is nothing but an electron's charge multiplied by delta V is equal to E. So delta V should be equal to E by small e. Once again the same method. What is E? 1.44 into 10 to the power of minus 18 divided by small e. What is it? 1.6 into 10 to the power of minus 19. When I do this, what will happen now? Let me calculate this. This will be 1.44 divided by 1.6 is equal to 0.9. 0.9 into 10 to the power of 1, which should be equal to 9 volt. Which means what? The drop here is seen to be 9 volt over here. If this is nothing but 9 volt over here, then this drop would be 3 volt over here, because series circuit, right? So totally 12 volt you get it across. We already crossed the time. Okay, we missed some time over here. Okay, so therefore, now what is your answer here? We need to get the value of R here. Okay, we still, what we have got is, we have got V and, sorry, we have got the potential difference here, we have got the potential difference here, right? Now what we do is, let us find out the total current. Total current is nothing but, okay, we already got VAB. VAB is 9 here. 9 should be equal to 12 minus 5 into I. Why is it 5 into I? This one, right? Okay, and so based on this I can write 5I is equal to 12 minus 9, which is 3. I should be equal to 3 by 5, which is equal to how much? 0.6 ampere over here. Okay, now 0.6 ampere is the current passing through. Potential difference across this is equal to potential difference across this, which means that the potential difference across the resistance, across this resistance, is nothing but I into R, right? I into R should now be equal to, how much is it? 9 volt, which you already know, 9 volt. Now I, you have calculated this, 0.6 times R equal to 9, which means R should be equal to 9 by 0.6. When you calculate this, you get the answer as 15 ohms, right? Though this appears to be a big, very big problem. Okay, so but still there is no other way. Okay, so you need to do all these steps. Maybe if you did not understand a part of it, you can put your comments so that I can do it once again, right? Then, so thus you have proved R equal to 15 ohms, which is for 4 marks. So how do you distribute those 4 marks? First mark will go for this calculation, understanding or how to find out the potential difference. Second mark will go for finding out the current over here. Okay, by finding out this value, this will be your second mark. This will be your second, applying this equation, this is your second mark. This will be your third mark, and finally putting all this and getting the answers, fourth mark here. If you just say, okay, some students do it, okay, just put I into R is equal to 9 and finally R is equal to something, the manipulation, you will not get the mark over here. Remember, you need to completely write this. Then calculate the power supplied by the cell. What is the power supplied by the cell? The power supplied by the cell is equal to I squared into R plus R. What is I square? We already got 0.6 square. What is R? 15. What is small r? Small r, small r. What is the value of small r? Small r seems to be 5 ohms. Internal resistance, right? 5. So it should be 0.36 multiplied by 20, which should be, how much is it? 7.2 watt, right? 7.2 watt is the final answer. Okay, and thus we come to an end to this problem. Thank you.